Hello everybody, we're getting ready to do 3.6, lesson 3.6 for SAT Math Level 1, and it's about quadratic equations. If you need homework sheets, note-taking sheets, tests or quizzes or online tutoring, email me here. If you need PowerPoints or video, email me here. Hello everybody, this is 3.6, quadratic equations. This part is SAT Math Strategies section, lesson 3.6. There's 24 points of notes, and there's 54 points of a skills sheet that's not included with this video. You would have to order that from me, which I have. So, overview of this section: a quadratic is an equation when the greatest exponent of the variable is 2, as in this here is a quadratic. A quadratic equation has two roots. Breaking down a quadratic into two first-degree equations, or your solutions for a quadratic. And to really find our roots, we need to use the zero product rule. For what values of x is x minus 1, x plus 3 equals 0. So we get to use our zero product rule here. X would equal 1. So your parabola for this would go something like this. And one leg of the parabola would cross here. Then the other leg would cross over here at negative 3. So it'll be x squared. Let's see, what would it be? Negative 3 when x equals 0. Possible values of x are 1 and negative 3. So here are your solutions here, 1 and negative 3. Solving a quadratic equation by factoring, we're going to solve it by factoring and not by graphing. So when we have a quadratic equation like this, it has a root of 3, x equals 3. So x squared would equal 9, so it's plus or minus 3 would be the solution to this equation here. So for x squared plus 2x equals 0, we need to solve for x here. Factor left side of the equation of the quadratic here. So we factor out an x. It's formed of two first-degree equations by setting each factor to equal to 0. So x equals 0 and x plus 2 equals 0. So what do we have there? So x equals 0, x plus 2 equals 0, x equals negative 2. So this would be a solution, and x would be a negative 2 would be a solution there. The two roots are 0 and negative 2. Does not have all the same side equation. You must put the equation into this factoring. So for example here, we have something like this. Then we have to move this 10 over here to the other side. So x squared plus 3x minus 10 equals 0. Factor the quadratic polynomial. This is what we get here by factoring out two binomials from this trinomial. Set each factor equal to 0. So we have x plus 5 equals 0, x minus 2 equals 0. So our two roots are negative 5, so it'll be negative 5 over here, and then 2 would be here. That would be where your parabola crosses. You can check that x and negative 5 and 2 are roots by plugging in each value into this quadratic and see if it is valid. Then we have something like this, where j is greater than k. If j and k represent solutions of the equation, what is the value of j minus k? Rewrite the equation in standard form here. So we're going to put everything over on the left side here, bring this over here. And then when we expand this out, we have this here. Solve by factoring. 2y plus blank question mark times y plus question mark. The missing terms are the factors of negative 27, so what could they be? We're going to try negative 9 and 3. Verify our replacement, so we got to verify if those two are correct. Multiply by using FOIL, like this, like that, like this, and then like that. So 2y minus 9 equals 0, y plus 3 equals 0. It does check. So y equals 9 over 2, or y equals negative 3. Those are your solutions. If j and k represent solutions, blah, blah, blah. So j equals 9 over 2 and k equals negative 3. J minus k equals 9 over 2 minus a negative 3. 9 over 2 plus 3. 9 over 2 plus 6 over 2. 15 over 2. Okay, if 4 is the root of x squared minus x minus w equals 0, what is the value of w? Since 4 is the root of the given equation, replacing x with 4 in the equation gives an equation that can be solved for w. This is what we come up with here. So 16 minus 4, 12 minus w, so 12 would equal w in this situation here. Quadratic equation with equal roots, x squared minus 2x plus 1. We have x minus 1 as a double root here. So x minus 1, x minus 1, x equals 1, x equals 1. Thus the equation a equals 0 has a double root of 1. That was 3.6 of SAT Math Level 1. If you want the PowerPoint or video, get a hold of me. Homework sheets, note-taking sheets, solution PowerPoints, email me here. Thank you.